Consider the following warehouse map and visual pick list. The blue dots are individual picks for a single order, all of which need to be picked by our RF user there next to the start. Now we see their pick path as dictated by a WMS-driven pick sequence, in this instance, Serpentine. The user will traverse each aisle that has picks in it, and in most cases, traveling the entire length of the aisle. In this example, they would have traveled about 934 feet. Let's look at the path that is generated using our pick path optimization engine. It uses a number of traveling salesman mathematical algorithms, crunching travel costs across a digital map of the warehouse. Now we see that we have significantly reduced travel time for our user. Instead of picking those picks at the bottom of our map in aisle sequence, we save a ton of walking by grabbing those at the very end. This results in an estimated savings of 18% for this order. All of this extra travel is eliminated. Now many of us have seen really sharp pickers in action, ones that can find workarounds or shortcuts that shorten this distance. But what about your newer pickers or your temporary force that you just brought in? Our engine helps to democratize these shortcuts, in addition to making our fastest pickers even better. Now that we can use math to help us build efficient routes, and now that we know which orders can be picked based on priority, let's look at the third component, intelligent batching. One of the key ways that warehouses can save on travel time is by batching orders. We now see a group of the next available orders in the system overlaid on our map. So we first see the pick path generated by our engine to pick order number 1, the highest priority in the system, traveling a distance of 432 feet. Most warehouses batch in a first in, first out manner. So the user will be assigned order number 2 to pick with order number 1 in their batch. Picking both together results in a total travel of 704 feet, much shorter than if they had picked them separately. However, there is a better way. Lucas's AI-based tools look at the pick path of all available orders in the system to help determine what an optimal batch is. Looking at the map, which order matches really well with our current pick path? If you noticed, order 6 in green almost matches our pick path perfectly and will make a great addition to our batch. We see only a small amount of additional travel is needed to complete both orders, resulting in 456 feet of travel to pick both orders. Consider how much greater the benefits could be once we pick batches of 4, 8, or even 20 orders. If that piqued your interest, please contact us about doing a no-cost travel simulation for your DC. Email us at jennifer@lucasware.com. Thanks for checking out our demo.